Hi students, good morning to all of you. Today we are going to discuss about coordination number topic. It belongs to complex compounds or coordination compounds chapter, right? In a coordination compounds, three members are present. One is the central metal atom, another one is ligand, and the third one is a counter ion. Central metal atom belongs to D block metal atom, and ligand is the chemical entity having a lone pair of electrons or charged species, and it can donate that lone pair of electron to the central metal atom and can form coordinate bond with the central metal atom. Hence, these compounds, that means the metal atom and ligand are connected, are linked through coordinate bond. Hence, they are called coordination compounds, right? And these two are represented inside a closed bracket, and these together we call it as a complex ion. And outside the bracket, you have to there that is a counter ion. So the ion which counters which neutralizes or which nullifies the charge of the complex ion is a counter ion, right? Now here our topic is a coordination number. What is coordination number? That is the total number of coordinate bonds or sigma bonds that are present between the central metal atom or ion and ligand is called coordination number, right? So this coordination number is different for different metal atoms in different complexes. Then let us do the different examples that are appeared in different competitive examinations, JEE Mains, Advanced, and in all type of questions will do with some typical examples also, right? So first of all, what is coordination number? Definition. How can I define? That is the total number of coordinate bonds or sigma bonds that are present between central metal atom or ion and ligand, right? Examples: potassium ferrocyanide. In this complex, iron is a central metal atom, it is a one member, and cyanide is a ligand, it is a second member, and potassium is a counter ion, it is a third member. And central metal atom and ligand you have to represent inside the closed bracket, and counter ion is present outside the bracket, right? Now, in this, the central metal atom iron is surrounded by 6 cyanide ions. You have to represent this one like this. The ligands are arranged around the central metal atom in such a way to give particular geometrical shape of the complex. Now these 6 cyanide ions, each cyanide ion have one lone pair of electron. They can form one coordinate bond, like that 6 cyanide ions can form 6 coordinate bonds around the central metal atom. So that's why here the coordination number is a 6. It is a monodentate ligand. What is dentate? Denticity means donor ability, which have ability to donate the lone pair of electron and to form coordinate bond with the central metal atom. There is donor ability is called denticity. So monodentate means it can donate one lone pair of electron can form one coordinate bond. Bidentate ligand means it can donate two lone pairs of electrons and can form two coordinate bonds with the central metal atom. Tridentate ligand, it can have three lone pairs of electrons and donate the three lone pairs of electrons and can form three coordinate bonds with the central metal atom, like that. Okay, got it? Yeah. Now, it is a monodentate ligand. So the in case of monodentate ligands, the number of coordinate bonds is equal to number of monodentate ligands, right? Got it? Yeah. Next, another example: Cu NH3 taken 4 SO4 cupramonium sulfate. Here central metal atom copper, NH3 is a ligand and sulfate it is a counter ion. So how many? It is a monodentate ligand. So NH3 is a monodentate ligand. So like that, four are there. They can form four coordinate bonds, right? So it is it can form. So four NH3 are there. Each one, their nitrogen atom have a lone pair of electron. Like that, four are there. So they can donate these four lone pairs of electrons and can form four coordinate bonds. Hence, the coordination number is 4. Next, another example. Take it iron Fe CO taken 5. Iron pentacarbonyl. It is a neutral ligand because CO is a carbon monoxide. As a ligand, you have to call it as a carbonyl ligand, and it is a neutral ligand. So it do not carry any charges. So that's why the central metal atom do not carry any charges. It is a neutral ligand. In all this are called metal. It is a carbonyl ligand. Metal carbonyls. In metal carbonyls, the central metal atom do not carry any charges. Oxidation number is 0. So that's why here oxidation number of the complex is 0. There is no counter ion. Okay. So only complex that is it is only present. It is a neutral complex compound, right? So here the iron metal atom is surrounded by 5 carbonyl ligands. So this is a monodentate ligand. So each one can donate one lone pair of electron and can form 5 coordinate bonds. So that's why coordination number of iron in this complex is 5. Next one, NiCO taken 4. It is a nickel tetracarbonyl. So it is a monodentate ligand carbonyl. How many are there? 4. So that's why the coordination number is 4. Around the central metal atom, 4 coordinate bonds are present. Okay, next one, silver. So NH3 ligands 2 are there and it carries plus 1 charge. So here silver is surrounded by 2 NH3 ligands. So coordination, it is a monodentate ligand NH3. So coordination number is 2, right? Next one, Hg, mercury, and take it here, iodine. Okay, and it carries minus 1 charge. So this iodine is, each iodine is minus 1, 3 are there, minus 3. And this is, this minus 1 comes this side, plus 1, and mercury is plus 2. And oxidation number. Now coordination number is, iodine is a monodentate ligand. So it can form one coordinate bond. So 3 are there, so that's why coordination number is 3. Got it. Next one. Another example, take it here, can ceric ammonium nitrate, cerium, NO3 taken 6 and 2 NH3, NH4 plus ammonium ion. So this is a ceric ammonium nitrate, can ceric ammonium nitrate. So the ceric ammonium nitrate is a complex compound. Generally, you came to know this is used as a agent in organic chemistry, right? Okay. Now here, a cerium, it is a F block element, right? No, it is a D block element. Generally, students are confusing here. Cerium is a F block element. After lanthanum, okay, the elements that are called as lanthanides, the lanthanides are from cerium to lutetium. So it is a lanthanide, F block element. Okay. Now here, a ceric ammonium nitrate. Here cerium is the central metal atom and nitrate ion, that is NO3, nitrate ions. Like that, how many are there? 6 are there. They can form 6 coordinate bonds. So coordination number is 6. Right. Next one. Take here, nickel, Cn taken 4 and carries minus 2 charge. So it is minus 4, it is minus 2 will come this side, plus 2, nickel is plus 2, oxidation number. And here cyanide is a monodentate ligand. So it can form 4 coordinate bonds. So coordination number is 4. Next one, nickel Cl 4 minus 2. Here the chlorine is also a monodentate ligand. So that's why each chlorine have one lone pair of electron can donate and forms 4 coordinate bonds, 4 chlorines. So that's why coordination number is 4. Next one. Continue here, cobalt N taken twice and Cl2 outside bromine is present, a counter here. Alright. In this case, En, it is a ethylene diamine. Ethylene diamine. It is a ligand. Just to represent structural formula, you know, ethane CH2 that is CH3 single bond CH2 ethane, right? And ethylene is CH2 double bond CH2. Here one pi bond that is replaced by NH2, that is NH2, two are there, this side one. So each nitrogen have one lone pair of electrons. So it is a ethane 1, 2 to the first carbon, one NH2 group, second carbon, one NH2 group is bonded. So that's why it is ethane 1, 2 diamine. Ethane 1, 2 diamine. Right? Now, this ethane 1, 2 diamine, if you write it, it is a very lengthy name, right? So that's why IUPAC committee suggested for this ligand, you have to represent the symbol En. En is nothing but ethane 1, 2 diamine. Have to keep in our mind. And here the donor atoms are nitrogen. How many are there? 2 are there. It can form one coordinate bond. It can also form one coordinate bond. So that's why around the central metal atom, 2 coordinate bonds are formed. This one ligand, ethylene diamine. So that's why it is a bidentate ligand. Density is 2. 2 donor atoms are there. So 2 coordinate bonds are formed. Right. So now here ethylene diamine, one ethylene diamine can form 2 coordinate bonds because it is a bidentate ligand. Like that here 2 ethylene diamine are there. So one can form 2 coordinate bonds. So 2 can form 2 into 4 coordinate bonds, and 2 chlorines is a monodentate ligand 2, totally 6. So coordination number is 6. Generally students are commit a mistake here. So they are saying sir 2 plus 2 is there, that is coordination number is 4. This is wrong. Okay. So because it is a monodentate ligand chlorine, but ethylene diamine En is a bidentate ligand, you have to consider. So each ligand can form 2 coordinate bonds. Next one. For example, look at here. Cobalt C2O4 taken twice, and this is NO2 taken twice, and outside here chlorine is present. Now, in this complex compound, C2O4 is a oxalate ion. It is also act as a ligand. You know, oxalic acid H2C2O4 formula, right? And the ion is oxalate ion. So oxalate ion formula, that is COO minus and that is COO minus, right? So here 2 donor sides, that is 2 oxygen atoms are donor sides. So they can form, one oxygen can form one coordinate bond, another oxygen also. So that's why it is a bidentate ligand. So each oxalate ion can form 2 coordinate bonds. So that's why like the 2 are there. So 2 into 2, that is 4, because it is a bidentate ligand, my dear student. Oxalate ion is a bidentate ligand. So that's why 4 or 2 are there. So the 2 oxalate ions can form 4 coordinate bonds, and it is a NO2. It is a monodentate ligand. It is a monodentate ligand. It can form 2. Totally 4 plus 2, 6. So here coordination number is 6, but not 4. Take care, my dear students. Okay, right. Next one. For example, if take it here, yeah. Up to here, all of you got it? Yes, right. Take it here, chromium, Cr, En taken thrice, and here Cl3. Chromium is central metal atom. Ethylene diamine, it is a bidentate ligand. Like that, 3 are there. So that's why the coordination number is 6. Next, cobalt Cn taken 6 and carry charge plus 3. So it is minus 3. So cyanide ions are 6 are there, minus 6. This minus 3 will come this side, plus 3, and cobalt is plus 3. Oxidation number. Now, see, here coordination number is 6 because 6 cyanide ions are there. They can form 6 coordinate bonds. Right. Next one. You can here a cobalt. It is surrounded by H2O and it is also surrounded by pyridine and also surrounded by chlorine. 2 are there, and outside here bromine is present as a counterion. Right. Here 3 different ligands are there. Among these, all are monodentate ligands. So what is a monodentate? Py is a pyridine. Students, some of the organic molecules which having pi bonds are also act as a ligands. Pyridine. Okay. So benzene is also act as a ligand because pi bonds are there. Ethylene is also act as a ligand. Okay, like that. Okay, so it is a pyridine. Okay, it is a ligand, monodentate ligand. So totally 2 plus 2 plus 2 6. So that's why coordination number is 6. Got it? Next one. One important thing here. Generally, some of the complexes, like for example, a Schrock catalyst, SHROCK, a Schrock catalyst. So in this catalyst, central metal atom is a molybdenum and ligand is a nitrogen. So it can form 3 bonds are there. One is a sigma bond and remaining 2 are pi bonds. By the definition I gave, the number of coordinate bonds or sigma bonds present between the central metal atom and ligand is a coordination number. Here nitrogen is a ligand. So here between the molybdenum and nitrogen 3 bonds. Among that, one is a sigma bond, remaining 2 are pi bonds. So that's why what is the coordination number is here. So don't confuse here. So 3 bonds are there. So coordination number is 3. No, that is keep in our mind a special note here. A special note. What is that is here? Special note. In counting the coordination number, pi bonds are not considered. Only sigma bonds. By definition, there is a coordination number is number of sigma bonds only. Okay. So that's why here the special note is in counting the coordination number, pi bonds are not considered. Pi bonds are not considered. Pi bonds are not considered. Only sigma bonds you have to consider it. Okay, got it? Is it clear? Okay. One more example, that is a familiar example. You can take it here. Magnesium. This is 1450. Magnesium and EDTA ligand is there. EDTA, ethylene diamine tetraostate. And this is only one is there. Right. And it carries plus 2 charge. My dear students, here magnesium is a central metal atom. Generally students have one misconcept, that is complex compounds, that is coordination compounds are formed by D block metal atoms only. Their central metal atom is D block metal atom only. No, that is not correct. The central metal atom, most of the cases act as that is D block metals and F block, but in some of the complex compounds, the S block elements and P block elements are also act as a central metal atom. So here magnesium is a central metal atom. It is a S block element, right? Okay. So complex compounds, aluminum is also there as a central metal atom. Okay, like that. So here magnesium central metal atom surrounded by EDTA ligand, ethylene diamine tetraostate. It is a hexadentate ligand. So that's why it belongs to polydentate category. So 6 donor sites are there, 6 donor atoms are there, 2 are nitrogens and 4 are oxygen atoms. Totally 6. So it is hexadentate ligand. So this one ligand, the EDTA, one ligand, it have 6 donor sites. It can form 6 coordinate bonds. So that's why the coordination number is 6. So don't confuse here. So EDTA only one is there. So that's why coordination number is what? That is wrong. So that's why the coordination number of the central atom magnesium is 6, because this one EDTA can form 6 coordinate bonds around the central metal atom magnesium. Right? Is it okay? Got it? Fine. So thanks for watching my video. Okay. So if you enjoy it, you can like it, subscribe it, and share to your friends. Fine. Okay.